Okay, so we're going to tie all this knowledge together, knowledge of combinations with probability distributions and binomial coefficients in something we call the binomial probability distribution, or capital B it's denoted. So the theory is, if we have a sequence of n independent trials, for example, when I toss a coin 5 times, the number of trials here would be 5, in which there are exactly 2 outcomes, success and failure, where the probability of success is p and x is the number of successes in n trials, then the probability of getting x successes is cnx times p raised to the power x, brackets 1 minus p raised to the power n minus x, where x can be 0, 1, 2, up to and including n. Okay, that doesn't say much, so let's do an example. We're going to find the probability distribution for the number of heads you get when you toss a coin 5 times. So, we say that x, capital X, is binomially distributed with a number of trials n and probability of success p. So in this case, our example is binomially distributed because we can either have a head or we can not have a head, and we have 5 independent trials. So x is binomially distributed with 5 trials and a probability of success a half. So we want to find, we can either have 0 successes, 1 success, 2 successes, 3 successes, 4 successes, or 5 successes. So the probability, according to this formula, probability of getting 0 successes is going to be C50 times the probability, which is a half, raised to the power 0, times by 1 minus p, which is the complementary probability, 1 minus a half, raised to the power n minus x, which is just going to be 5. So we can do this in our calculator. Do NCR 50, which is actually just 1, times by brackets a half raised to the power 0. Well, any number raised to the power 0 is just going to be 1, but we'll do it anyway, times by brackets 1/2 raised to the power 5. Okay, it's 1/32. However, for the probability of getting 1 head, we have to do C51, 1/2 raised to the power 1, times by 1/2 raised to the power 4. Don't know if you can see that there, so I'll just make that a bit clearer. 1/2 raised to the power 4. Do the maths, let's do the calculation. Just copy this and change the coefficients. Now I've got 5 NCR 5, 1, 1/2 raised to the power 1, and 1/2 raised to the power 4, sorry. 5 over 32. And so on. Let's do the next one. That's going to be 5, choose 2, 1/2 raised to the power 2, times 1/2 raised to the power 3. 5/16, or 10 over 32. Five, choose 3, 1/2 raised to the power 3 times 1/2 raised to the power 2. The same. And then I think this probability distribution is symmetrical, so if we do, let's just do that for completeness. Notice that the coefficients of these two always add up to n. 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, and so on. So the least likely events is getting no heads or all heads, and the two most likely events are getting either 2 heads or 3 heads. So that's an example of a binomial probability distribution.